code.
There are two possibilities. One, the header will declare where I want to participate, such as an IPA path, I want to optimize, I will not optimize, or subject to so command line options.
So what you are saying is the function
will declare that I am so and so. Okay. Alternately, it can look at actual command line parameters and do nothing or do something. That's the option. Is there any third option?
Do nothing is one design choice.
Yeah.
So the function pointer is pointing to a function that does nothing for minus O1.
Okay. Any other flags like enable for O1 or enable for O2? Enable for O3.
No. In terms of code, I want an answer in terms of code.
So this linked list is a dynamic one, number of pointers to the next pass. It is a fix.
It's a fix. Okay. Yeah.
The actual code in the path should take care of the server.
Okay. Actual code in the yeah.
So as you said that path manager is nothing but a kind of loop. It says that
yes.
these passes are there
yes.
to continue different passes.
Yes.
As you said that O1, O2, so that while loop parameter might be dynamic. Considering that
this linked list is a dynamic.
Okay. Any other suggestion? I mean, I would like to get all the suggestions and then I'll distill them and summarize.
The call has to go to the driver inside function because it may require more look at command line parameters. There may be custom parameters which even GCC has not heard of.
Any other guess? Yeah.
I'm just guessing, is it possible at the entry of every pass to have a small code which checks whether this pass has to be completed or it has to be omitted, looking at the command line parameters. And if it is to be bypassed, then the rest of the code can be put in another condition which is not executed directly, move to the next pass because the pointers are fixed. So probably eliminating a node would not be possible, but checking at the entry of the node and then going to the next node if it is not to be done.
Any other remarks?
I think based on the for different optimization level, I can do it differently.
Yes.
That can be one. I don't know.
That can be done.
But you can have options where you save that particular path in command line, which means you have to have some checks. I will build different linked lists for different optimization levels. Yeah, optimization level. But then you're able to use the switch for the same particular path. One switch at the top of the path manager. So you would probably have you'd suggest in that sheet suggest that they have a flag that's checked. So if this is set for true or false, then you execute it or not.
Okay. Let me give you a hint. We saw an answer to this question yesterday. Does anyone remember? Let me give you one more clue. I showed it as an example of a generation related gap. Do you recall what we talked about? I showed you a function called gate tree loop distribution. So, the suggestion that you have given, both the suggestions are included in GCC. Okay? So, on the one hand, for every pass there is a predicate function, there is a gate function. Okay? The pass will be executed only if that gate function is true. Okay? And that gate function checks a flag. And who sets the flag? The flags are set by the command line pre-processing. So, command line options are read and appropriate flags are set, and a pass will be executed if the appropriate flag has been set. So, that's one option. And the second option, as Dhananjay said and you are saying, is again to organize the list into different kinds of passes. Both the things are done. So, it's not, I have shown you for simplicity a single list here. There are actually 5 lists which are invoked in different contexts. It's not that all those 5 lists are executed one after the other. One list is executed, something else is done, then maybe some other list is executed. So to summarize, there are both the mechanisms. Based on the command line option, a decision will be taken which pass list to execute. At the same time, for every pass, there would be a gate function, and we will see the exact data structure in maybe 5 minutes from now. Okay? So this is the way the passes are organized. How do we get a front end? So there's something called lang hooks. So look at the way GCC uses terms inconsistently. For hooking up a translator, no name is given to that concept. It's just a structure, it's an array. For language, for bringing in a language front end, it's called a hook. For bringing in back end, it's called something else. For bringing in dynamic plugin, it's called a plugin. Okay? We would like to call all of them as plugins. So what happens for a language specification is that there is something called lang hooks. Again, it's a structure. Okay? In this structure, I specify what is the name of my parser, what is the name of the function that's going to do semantic analysis, etc. We will see the details. So all that I do is, when I have to include language 1, I essentially set up my hooks. I essentially tell GCC that this is the name of the parser for my language. This is the name of this particular function for my language. And how do I tell here? Here we do not use function pointers. In fact, we use function pointers, but we do not include them in a structure directly. We will see just now how we will include it. But the important point is, if instead of this language, I want to include some other language, and this is decided at build time, I might specify minus enable language is equal to C. Instead of that, I might say minus enable language is equal to C++. So I may want to include different things, in which case, all that needs to be done is what is held in that lang hook structure changes. So we have something else being included in the lang hooks. If you want to include a third front end, this changes. That's about it. At an abstract level, that's what it is. Coming to the machine dependent part, okay, we made one observation yesterday, an important insight of the Davidson-Fraser model, which said that register transfers are target dependent, but their forms are not. Or rather, their forms are not target dependent. They have same structure. So one could visualize a program that works on the structure. Visualize it as a, let's say, a tree structure. A tree, you have a node, and the structure layout of the tree is fixed. What could change is whether this node has these details, those details, those details. So details, attributes of the nodes could change. Now imagine a situation where I write a program that generically works on the tree structure at the top level. Okay? And the attributes of the tree structure are isolated in a separate data structure. So I have a data structure. Whenever my function has to process this tree node, it's going to consult an appropriate data structure. And it will perhaps call some other function, it will figure out the size of the data, etc., etc. Okay? This is precisely what is done in GCC. There is this structure called INSN data. Data about the instructions present in a target. Okay, this structure is created and this is generated for machine 1. I would generate a recognizer code. Generating this is very trivial. We will see this tomorrow in more details. This also we will see in far greater details tomorrow. But the whole idea is the expander code. So we have for machine dependent part, we have an expander and we have a recognizer. The expander code is generic. It has an array called optab table, which has pointers to functions that will generate code for different things, different operations. Okay, so we set a pointer to this, and this file is generated. So if I want to talk about machine description 2 instead of 1, all that I need to do is to generate this recognizer separately and make sure that this generated code has pointers to INSN data of a different kind, and so on. So these are at a very abstract level plugin mechanisms in CC1. What we will do is we will look at some details of this, but we are not interested in too much in the front end. So we will just look at an example. This is where we are going to focus more. We will look at quite a few details. The assignments that you do today will require you to do something related to this. These are the details that we shall see tomorrow.
Sorry?
Yeah.
How is data passed from one path to another?
Good question. How is data passed from one path to another?
It is internal documentation that GCC does not have.
Internal?
The internal detail that GCC does not export.
No,
through the intermediate
it is an internal detail. It is not too hard to visualize. Yeah.
through the intermediate representation.
No. I mean, obviously, information will have to be in the internal data structure. The question is, how does it go from one pass to the other pass? Because his question is very important. Because these passes are written independently. When I write code for pass 1, it doesn't even know that there is something called pass 2 exists. In general, in principle, they are completely independent. Absolutely. Global variables. So the entire information is held in global variables. And today in the afternoon you will write a pass which traverses this global data structure. So you will have to write a pass that prints global variables, local variables, that tells callees of a function, callers of a function, etc. So a short answer is global variables. There are no parameters. So in general one would expect that maybe there is a pass, or one could expect pass 1 and pass 2, pass 1 computes something and passes it as a parameter to pass 2, but that's not the case. Okay? All these functions are, all pass entry functions are parameterless functions. Yeah? So his question is that a good software engineering principle? Software engineering requires us to make sure that the information flow between modules is minimal, right? The modules are, we do not expose too many things to different modules. You know, principle of information hiding, encapsulation should be there. So his remark is it a fair thing to do? So the answer to that is,
let's say given 10 passes, demand that there are 2,000 kilometers, and as good software engineering, we design a one piece structure having 2,000 variables for storage specific data. Everybody imports the data and deal with all the 2,000 variables. Okay? Currently, clean engineering, the 2,000 is a problem. Tomorrow, if there is a new pass, you need to add 2,000 first. Am I right? It means all other passes become invalid. Right? Because the structure is that. How do I deal with this add-on? And there are going to be so many people writing so many tasks. I guess as a democratic citizen, I have right to write everything. I have to
So yes, it's through global data, but the structures are well defined. I mean, most often we don't have global scalar variables. There are very few scalar variables. Most of them are couched inside a structure, and you access variables through that structure. In fact, what happens is, we will see examples of how do we re-initialize our data structures when we process one function and then we go on to process other functions. You have to pick up a different control flow graph, right? You have to pick up different data structures. So there are APIs defined for it. But yes, yeah.
Single-threaded process, right? So
Whatever you're doing, speaking.
Where would the issue of and global variable where will the construct come in? We deterministically know that when did the variable's value change when input changes?
Yes and no. Yes, because that's how traditionally it has been in GCC. No, because it's going to change. It's going to change when you bring in link time optimization. People visualize parallel threads processing different functions in different ways. So so there will be a need whereby, again, you could say that, look, that function's data and not this function's data. But still, at one level, it's all combined. So there is a parallel process, there is a sequential process, then there will be another parallel process. So something will have to be done about it. Yeah.
Does that mean that there are certain passes which are independent of other passes and they can be executed in parallel?
Every pass is independent, in principle independent of the other pass. Every pass essentially takes a Gimple representation and processes it. Now it's possible that some passes may make an assumption. Okay, so there are, when we look at the pass data structure, I will answer this question in greater details. Yeah, that's a good question.
So, but are there so many locks to be provided on the global variables that I am using this area?
No.
Don't touch.
No, there is no lock at the moment. There is nothing.
Parallelism is only hypothetical.
At the moment, it is hypothetical, but when it is brought in, it will be brought in a very limited context. It's not indiscriminate parallelism. It will be brought in a situation where we know that we can do these things in parallel. Yeah, I think some of the questions will get answered when we look at the data structures. But I would not like to stop you from asking the questions. I mean, I'm happy about the interaction. So, if there are any questions, I would like you to raise now or raise them when the questions come. Should we proceed? So, this is the overall picture. This is an abstract picture. And as you can see, an abstract picture does bring out many questions. So, now we need to go into the details. But remember this picture. I mean, when I said we talk about essential abstractions in GCC, this is one of the essential abstractions. Okay? And we will see later that this is also not completely precise. That's what brings out the design flaws with GCC. Okay, so here is the front end plugin. So you can see here that so this is important. This is the struct lang hooks, which is instantiated for C. So the way I specify it, I say hash define lang hooks finish C. So there is a C common finish. This is the function that will do what is required after parsing. Okay, lang hooks parse file is C common parse file. C write global declarations is a function. In fact, this is a function that will execute after parsing. So you can visualize what happens. There is a structure called lang hooks that has fields which are defined in these capital letters. Lang hooks finish, lang hooks expand expr, lang hooks parse file. These are the generic names given there. Now when I write my own front end, I say hash define lang hooks parse file. So C processor will end up replacing those capital letters with this function, and this is how function gets included in the structure when we build GCC. How do I specify intra-procedural passes? So this is struct opt pass. Opt stands for optimization. So this is how an optimization is specified. There is an opt pass type, and we will see what it means. There is a name of the pass, and this is the name that is used this is the name that is used as extensions, file extension. So whenever you see .cfg, if you want to find out which particular file has generated which particular dump, let's say you want to find, so we saw one example called C unroll I. If you want to find out which pass has generated, you search for instances of C unroll I, and you will find a structure where you will find this name in string, and that's the pass structure variable that is responsible for inclusion of this particular pass. So this is the name. This is bool star gate, function pointer to gate, and this is what I meant by the predicate for if this gate allows a function to be executed, function will be executed, otherwise it will not be executed. And this gate will essentially consult the command line options. Appropriate flags would have been set based on O1, O2, ON, etc., etc. We will say, okay, I want to execute this pass, or maybe I don't want to execute this pass. This is the most important function, execute, star execute. This is the entry function of the pass. So in order to execute this pass, we need to essentially look at this function. This we have a sub pass. If I want to execute this pass, if my gate says, yes, execute this pass, then I would like to execute this function. But before executing this function, I must execute these sub passes. So that was the question. Can I say all passes are independent? if I want to make sure, for example, let's say I'm doing my data flow analysis, so I want control flow graph to be constructed. I can't work unless control flow graph has been constructed. So, in principle, I could specify control flow graph creation as a subpass, which ensures that the prerequisite passes have been executed. Okay. Apart from prerequisite passes, there may be post-requisite passes. After executing this pass, you make sure that maybe I do some analysis, and after the analysis I want to do transformations right at them, and I don't want to include them in my main function, in my execute function. So I can give next pass. So what is the next pass? List of passes. So I can, for a pass, so look at the way we can control things. There is a predicate function which decides based on the maybe command line options or maybe something else, which decides whether this pass is allowed to execute or not. Then there is something that says that before this pass, execute these passes. There is something else that says after this pass, execute these other passes. Okay. And there is this static pass number. Generally, compiler will assign its own number. You can fix a number. Okay. They are same structures. Yes. Yes. So look at this. This is struct opt pass, and subpass is a pointer to struct opt pass. Okay. Similarly, next is also a pointer to struct opt pass. Right. And then there are the other fields: properties required, properties provided, properties destroyed, to do flag start, to do flag finish, etc., etc. So the structure has been designed keeping in mind the needs of a person who writes the pass. Most of the things that you want to do can be specifiable in terms of this. It's a fairly well engineered structure. Now you could have something called a Gimple pass, you could have something called an RTL pass. So then there is something called a Gimple opt pass, which is, so opt pass is the original data structure in GCC. Gimple came in later. Initially we didn't have Gimple at all. So which means that the same structure for a long time was shared between Gimple as well as RTL. And this doesn't say anything about whether it's a Gimple or RTL. This is just a plug-in mechanism. It's a data structure that allows me to hook in different functions. Whether those functions work on Gimple, whether those functions work on RTL, doesn't matter. I don't care. It's just a top-level mechanism, right? But later people realized that maybe we should have a separate specification for Gimple and RTL. So therefore they couched the whole thing into a new structure. So Gimple opt pass now has, it's a structure with a single field, which is nothing but a struct opt pass. Okay, and similarly we have RTL opt pass.
Sir,
Yeah.
the pass and next, do they specify as one previous and next pass or a list previous and next pass?
Okay. This is a structure to the same thing. So it will be one single pass. And that pass will have to have some other sub pass or previous pass. Yeah.
So this list is fixed at the compilation time of the GCC, right?
Yes.
Where does the dynamic thing comes into the picture?
We will see. We use the same structure for dynamic plugin as well. The intuition is very simple. All that we want is, if I go here, I have this list. Now, because this is a linked list, we all have in our first programming exercises written programs to add a node and remove a node in linked list. Right? Now, either I specify my linked list at compile time, or at runtime I have a routine that adds a node in the linked list or removes a node in the linked list. Dynamic plugin is nothing but add a node in the linked list. That's it. We will see how it starts.
But it needs a recompilation of the thing.
It gives a
Recompile.
no, dynamic plugin doesn't require recompilation. Static plugin requires recompilation. Yeah.
So your structure is having a pointer to sub and next.
Yes.
Does that mean that these passes are not linear? There may be, at some in some paths there may be some sub passes which may have some next passes.
Yes. Yes. It does mean that you can specify not even tree. Maybe if you're not careful, it will become a cyclic graph, but you can specify a directed acyclic graph. It's for you to decide. GCC has given the data structure. So it's possible that what you call as a subpass may have already been included in the, so there is another list. So there is a list of passes each pass has something, and each of these passes would have some subpasses, and this structure may point to that particular node. It's possible for you to do that. So that's what I meant by saying the structure is quite general. The plugin mechanism is quite general. It has only one problem. I mean, it's all very nice, very good software engineering, but it's something which I as a compiler writer hate. And the reason why I hate is it doesn't give you a call graph of the GCC source. I want to do my static analysis. I want to know which function calls which function. Looking at the code, I cannot predict which function is calling which function. There are ways of creating call graphs, but they're very imprecise, and that creates a problem for static analysis. In fact, one of the important PhD problems, and Swati is going to explore that in details, is how to create a precise call graph in the presence of function pointers. There are many issues, there are some interesting ideas, but this is one structure that complicates the lives of static analysis people like me. It's otherwise very useful structure. Okay, so that's the data structure about a pass. Let's come to, so now this is the pass variable, all simple IPA passes. Okay, we have this struct simple IPA opt pass. So we'll know in a while what is a simple IPA pass, what is a regular IPA pass. I won't be able to say in advance what it means, but by the end of this lecture, we will know that fairly well. Okay, but there are two kinds of interprocedural passes in a nutshell. Okay, so let me begin with the first principles. What is an interprocedural pass? An interprocedural pass is something that's going to work on function 1, then it's going to pick up function 2, then it's going to pick up function 3. That's an interprocedural pass. Because GCC allows separate compilation, I may have F1, F2, F3 in this file. I may have G1, G2, G3 in this file. When does this pass work on F1, F2, F3 and G1, G2, G3? So the answer to that question is, we have two kinds of interprocedural passes. One kind of interprocedural pass is which works on functions in a given file. That's called a simple IPA opt pass. Works on a translation unit. This translation unit may not be a complete program. I may not have a main function. I may not have a call graph that is complete. I may create a call graph. For all I know, I may have F1, F2, F3. None of these functions call each other in this file. It's quite possible. So I'll get a call graph which is just a collection of nodes with no edges in between. Right? That's quite possible. So I would still like a facility where I can work on across functions in a file. What do I do with is a separate issue. This is a useful interprocedural analysis that I can do without knowing the call structure. For example, I would like to know which function, I would like to know what is the size of a function. I want to take an inline decision. Okay, I'll figure out later whether it is recursive or not, but let's say it's a small function. If I know that it's a 3-line function, then I'll mark some flag somewhere. Yeah, maybe it's a possibly inlineable function. For that, I don't need to look at the other functions. There are passes, there are interprocedural passes that can work on a single translation unit. These are called simple IPA passes. Okay, the next structure. So this is a plugin for interprocedural passes on a translation unit. There are interprocedural passes across a translation unit. Now I would like to process F1, F2, F3, and then I would like to move on to G1, G2, G3 before moving on to the new pass. These are called IPA opt passes or called regular IPA passes. And these are the passes that get invoked in link time optimization. That's the LTO business that we'll talk about. Looks quite complicated, but remember the first structure is just struct opt pass. So first structure is this structure. First element is this particular structure. Okay. There are additional things. What are those additional things? Say a function to generate summary. So I may want to process a function and I may want to generate a summary information. A function to read summary from, where from? We will see in a while when we talk about link time optimization. A function to write summary. A function to write optimization summary. I may want to decide on some optimization criteria and I say, okay, I can do this optimization. So I can write it there. I can say read optimization summary, and this function transform is what will actually do the transformation, etc. So this is an interprocedural pass. The way, so this is also an interprocedural pass, but this is restricted to a translation unit. So this pass assumes that all the functions are in the same call graph. They are known to me. This pass is across translation units. So this pass says that look, I don't have all the functions right now. So I may want to process F1, F2, F3, dump out the data in some form. Then I'll process G1, G2, G3, dump out the information in some form. Then I may want to collect all those informations. And then I may want to process them again. And this would happen at link time. And therefore I need things like read optimization summary, write summary, generate summary, and those kinds of things. And this is where we will see parallelization can be brought in.
When I'm compiling a file which has say 10 functions,
Yes.
At that time I'm not generating any summary.
I am. Yes, I am. By default, I am. If I give minus FLT option now. If I don't give, then I am not.
Okay. So if that minus FLTO is there, then the regular passes are still called. All regular IPA passes are called and summaries are generated and checked.
Yes.
But that summary is used only at the link time.
Okay, we will look at more details of this later. I'm sorry if you hear me saying, if you feel that every time I keep saying we'll look at the details later, but we have to begin somewhere. I have to first present a big picture and then go into the details. Okay, so these are the predefined pass lists. All lowering passes we saw, there are 12 all lowering passes. There are all small IPA passes. These are early optimization passes. They also invoke intra-procedural passes over the call graph. So these are basically restricted to a translation unit. All regular IPA passes, these are across translation units. And these are all passes, the remaining intra-procedural passes on Gimple and RTL.